So you did a little activity. In the activity, you needed to figure out about the black box without actually looking inside. Now, how did you go about doing that? Yeah.
I churned it to feel for any place. Like I listened while I churned, and I could feel slight vibrations if like it hit something. And then if I felt it like not moving along the edge, I would continue to churn slowly until I heard it drop off. Or
Excellent. That's what most of you did, correct? You were like listening to it, shaking it, those types of things. Now, when you were working alone, did you come up with an idea of what you thought the inside would look like?
Yep.
Okay. When you went to work with a partner, did your partner have the exact same idea?
No, ma'am.
Not always. So then you had to talk it over with your partner about what you thought the inside looked like. Did you come up with a new plan?
Yeah. Yes,
Did it have aspects of both of what you heard?
No, ma'am.
No? Not this time?
No.
All right. And then when you opened it, smart Alec. When you opened it, were some of you right?
Yes.
All right. Those of you that were wrong, did you see that there were some things that explained why you heard what you heard?
Yes.
Okay.
Okay.
All right. So, could you be wrong and still learn stuff?
Yes.
Yes. So here's how it works with the atom. You have this, basically this thing you can't see. And you run tests on it. And you learn about it. Now, there's no guarantee that we know everything that's inside the atom. Just like there was no guarantee that you knew everything inside your box until you opened it. We can't open the atom, so there's no guarantees. But are there clues to help us figure things out? Absolutely. Now, what happens if I give you a tool to help you learn about the inside of your black box? Maybe a magnet. Would that help you learn more?
Yes.
Yes, it would. If you happen to have one of the boxes that had a steel ball, you would learn, oh, this ball works with the magnet. I might be able to figure out the inside better. What if you were one of the people who had the box with the penny? Is penny magnetic?
No.
No. So you would learn, whatever I have isn't magnetic. Can you learn from something not working?
Yeah.
Absolutely. All right. Along comes somebody with an X-ray machine. Could you learn more?
Yes.
Yes, you could. Even without opening the box, you could still learn more because you've got a new piece of technology. Now let's talk about technology for a second. I asked you last night, or at the end of the day yesterday, to think about two things. One, how do we know about the atom without actually being able to look inside? How do we know what we know? And two, if you are not naturally smarter than somebody before you, how do you know stuff? Those are the two things that we talked about. Now, we already had a little bit for the naturally smarter. We've already talked a little bit about how we know what we know. I want you to think, a lot of times what I get is how come we know more? A lot of students say that the answer is technology. How many of you guys think that we know more because of technology? One word answer. A lot of you. I would say half of you. Your instinct for that answer is we know more because of technology. I want you to think about that for a second. How do we invent technology?
From smart people.
But smart people aren't any smarter now than they were before. Think about it. Let's look at the iPad. Latest high-tech technology.
I know that.
Yeah.
They have another one.
Now, could somebody 1,000 years ago invent the iPad?
No.
Yes.
Made out of
Well, no.
Yes.
Yes.
Resources.
Yes.
a rock.
Yes.
Well, there's a problem. 1,000 years ago, did he know about electricity?
No.
Oh, yeah.
Could he invent the iPad if he didn't know about electricity?
No.
No. Electricity is a big topic. You could spend a life, if you have to discover it for yourself, If you have to go out and figure it out for yourself, you can't get it from a book. It could take a lifetime just learning about electricity. He'd have to learn about circuits. He'd have to learn about semiconductors. They're a special kind of circuit that's used in computers. He'd have to learn about computers. Realistically, here's 5 things here. Each of these things takes a lifetime to learn about. Somebody who doesn't know about electricity can't invent the iPod. Doesn't matter how smart they are. Now, if somebody else figures out stuff about electricity, writes a book, could somebody take a lifetime's worth of knowledge and put it into a couple of year classes?
No.
Yes.
Yeah, you can. Well, think about this. I'm going to take today one guy's life, and I'm going to sum it up in 15 minutes. His whole big thing. You know, each of these, there's about 6 dead guys that we're going to talk about.
Albert Einstein.
He's not one of them.
Thomas Edison.
5, 4. Each of these guys has something to do with the atom, which eliminates Edison. And Einstein would be in there, but he's way beyond. We're starting at the beginning. Now, these guys literally spent their lives learning what I'm going to teach you. Like, I'm going to spend 15, 20 minutes on each guy. 20 minutes. You're going to know what some guy may have spent a lifetime learning. That means that if you learn what a bunch of people have learned, you might jump off and invent the next thing, which in turn might help somebody else learn about something else. That's how science works. It's not that you're smarter than the people before you. It's that you build on the people before you. You're standing on the shoulders of giants. You're working with the stuff that people have spent their lifetime working on. Now, am I going to give you everything that these guys studied in 20 minutes? No, I'm giving you an introduction. But realistically, if you spend, a chemistry class, a high school chemistry class, you can learn in 1 year, in a high school, 1 year, 40 minutes a day, what literally took 15, 20, 30, 50, 100 people a lifetime to learn. And because you can learn that stuff 45 minutes a day for a year, you can go on to the next 100 people, and then 100 people after that. And then eventually you can get to the point, if you narrow your focus and say you only want to work on this kind of thing, you could jump off and invent the next thing. Now, if you like technology, you might not spend as much time working with chemistry stuff. You might be working with semiconductors, computers, circuits, but you're still going to need physics to learn about some of this stuff. So you learn the science helps create the foundation knowledge to build the technology. The technology then helps you try new things, which moves the science, which helps move things along to build more technology. You can't build an iPad when you don't know about electricity. Does this make sense? Do you see how technology and science kind of are interwoven? They work together? Yeah.
So basically, people's built off of other people's observations and stuff.
Absolutely. Absolutely. You don't have the time to discover it all for yourself. Yeah, it would. It'd take a lifetime. And you just don't. If you have to discover it all for yourself, you're not going to get even to what we know now. You have to have it kind of consolidated so that you can get through it quick, so that you can move on to the next step.
What about like Apple? They invent like hundreds of stuff like iPods and iPads and all that stuff.
And people will take those things and they will use them in new and interesting ways.
So like how do they create those all like within a life?
Well, that's because they have all of this foundation knowledge. They know all this already. So they can invent several things at this level. The iPod Touch and the iPad and the Nano, all those things have kind of even technology level. People that are working on beaming people from one place to another, that's the next step. Okay, do you see what I'm saying? You know, you've got to learn something between here and there. All right. So that's kind of the answers to the questions that we were talking about yesterday. And they're kind of the leading questions to what we're talking about today. We're talking about the history of the atom. And we're tracing the history of the atom through about 6 old dead guys. I refer to them as old dead guys for a couple reasons. 1, most of them were old. 2, all of them are dead. 3, they're all guys. It's history. Sorry. 4, it usually makes kids laugh a little bit. So that's why I call them the old dead guys. I know that some people, they get a little bit offended that I just, sometimes I do. But that's why I do it. They're old, they're dead, they're guys, and it causes students to laugh at least a little bit. So that's why I call it that. Your job, you need to identify the order that the guys come in, how the guy contributed to our idea of the atom, what he thought the atom looked like, and what he called it. You may want to take a second